So what I'm trying to show, two different populations. One is or has a mean of 16 and standard deviation of 2. The other mean of 14, standard deviation of 2. If you don't understand what the population is, let's say population 1 is the number of days to see effects after therapy. Good. So you keep going to therapy and then you wonder, well, how many days does it take? People did a survey, whatnot. The population 1 is a null. So we are saying that the average is going to be 16, probably has a standard deviation of 2. The actual population, again, in reality, we've done the population. The only reason I'm doing it this way is because we both done it this way. Can you see better? Yes? Okay. So this is evidence. So the second one that I'm going to plot. So what we claim is that the number of days on average to see effects of therapy is 16. You can ignore the standard deviation. What the data or evidence gives us is that the average is 14, standard deviation of 1. I'm going to graph this. The one that we assume will be in blue. The one that data will give us, in other words, you observe the entire population using a study, and that will be in sun. Let me adjust the limit so you can see better. Okay. So that's the picture we get. Yes. Now, looking at the picture, do you believe that there is evidence to support our claim that it is 16? So claim is in blue. Red is what we get from this sample. Is there evidence to support the claim? Riley?
I'd say no.
You're saying no, there is no evidence to support the claim. Why is that?
Oh, no, I wouldn't say significant.
No, you wouldn't say it's significant.
Yeah,
So
there's a couple that are on the 16 for the SAM. Yeah, the SAM is evidence, right?
yes.
So there's maybe a couple.
See, that is the purpose of statistics. Given this overlap, could we conclude one way or the other? That is our entire objective, right? Given that overlap, what can we say? Should we agree with the null or the
It's not.
You can ignore one. Not required. Just look at this picture. X, I'll put that part. X simply is the number of days. Good. What do you say?
It's hard to know without.
It's hard to know, right? There is a good amount of overlap. So in this case, what type of test am I doing? Am I doing a unidirectional test or a bidirectional test? If you do that homework, you'll know.
Bidirectional.
What is your name?
Amanda,
Amanda says bidirectional. Why is that, Amanda?
because there's two.
There is two of one.
Two.
That doesn't make it bidirectional. Bidirectional is correct, but why? The answer is right here. What I claim and what evidence I have.
Because you would set the null to equal 16.
Very good. So I'm claiming that the number of days is 16. To find evidence against the claim and set, the null is number of days 16. So it's either going to be higher than 16 or lower than 16. And we want to know if it's significant or not. Here it is lower, but it is not statistically significant. From experience, I know there's a good amount of overlap here. Yes? Mind you, effect size does not come into play unless you determine statistical significance. Good? Now, oops, didn't mean that. Same picture, I made a change, and I ended up getting this. Yes. From experience, you will reject a null. You will conclude that there is a statistically significant effect. Now the job is to assess, is there practical significance or not? I drew two lines that go through the average right in the middle. The distance that you see from here to there to there, is the effect that you observe. Good. So on average, how many days do we see as difference? 8. So the statistical test tells us we see a significant effect. The practical significance that I see, 8 days, that seems reasonable to me. Yes, good amount of difference. So this is a case where I will place faith in the test and say, yeah, conclusion is correct. It is not 16 days. I'm going to use the same effect size. In other words, I'm not going to change 16 and 8. But I'm going to do something and you can tell me if we will end up with the same conclusion. Go ahead,
What's the middle part, like what does that represent?
this line.
Like the two lines, like how far?
Oh,
apart
I
they are.
just drew a line to show the distance in between is the effect size.
The best part.
So I drew a line through 8, a line through 16. So 16 minus 8, that distance is the effect size. Now, the same case, I'm not going to change the effect size, but I'm going to change something else, standard deviation. And you can tell me if the conclusion is the same. Would you still conclude that it is not 16, the number of days? To see effects of therapy is not equal to 16.
Yes.
Alyssa shrugs.
I said yes,
Why?
because the effect is still the same,
Okay, but something changed.
yeah, the same deviation.
So here, no overlap. Yes. There is overlap. Right? So are we getting sure or less comfortable in concluding that there is an effect? Right?
Less comfortable.
We're getting less comfortable. Reason being, I'm getting an overlap, so I want to assess using a statistical test. If the statistical test concluded that we have an effect, and then you look at practical significance by measuring this distance, then sure. Yes. Okay, one more case.
I have a question.
Yes. Paul.
So we don't want the overlap, we want two separate, graphs, like two separate bell curves.
If we see it this way,
Yeah,
then there is definitely an effect,
okay,
because this is what you assume, evidence is going away
okay.
from, what you assume. But other cases, we have overlap and we're not sure.
So we do another test,
Yes.
okay.
Now, here is another case. This is where things get tricky. Oh. Good. Go to just picture. Let's see. Hello. I'll increase it a bit, see what happens. Oh, yeah, this is still messed up. Maybe I'll do it in separate rows. And then we can go back and forth. So this is going to be in blue. Blue is our reference. Salmon is what the data is going to give us. Okay. So right now, it's at 15. So we agree. 15 and oops, that should be set. 16. Very narrow at 15. Good. Now, if I asked you, well, could I say that the number of days to see effects of therapy is less than 16? So we reject the no. Would you agree or disagree by looking at this? A good amount of people gave an answer when they started feeling effects. Based on that study, this is what we have. So by looking at this picture, would you say, yeah, it is 15 or no? Sorry.
Yeah,
Why?
because it's supposed to be like almost no one said anything about it.
So the gap there is the variability. There is no, or not a lot of variability among the people who said, or who responded that these are the number of days when I started feeling effects. This is close to that, yes. Now, will we reject statistically? Yes. How do I know? From experience. We are going to reject it statistically. Practically, though, do you think it's a significant effect? So I'm going to reject statistically and conclude the number of days when people see effects from therapy is not 16 because I observed 50. Practically, do you have a good amount of effect? Sarah, why not?
It's just one good difference.
It's a 1 day difference, right? It's just about 1 day. Previous cases, at least I've got 8 days. Here, 1 day difference. Sure, statistically, I know from experience, the answer is going to be reject the null. There is an effect. The number of days is not 16. 15 is statistically significant from 16. All of those conclusions. However, from a practical standpoint, the effect size is 1, right? Approximately. 1 day difference, practically, is it a significant difference? No. See the difference between statistical significance and practical significance? Okay, we will do these for each of the tests as well. Okay, good place to start.